In this video, we'll write the balanced net ionic equation for HF plus KOH. This is hydrofluoric acid plus potassium hydroxide. The first thing we do with net ionic equations, we balance the molecular equation. But this equation, it's already balanced, so we're done with that. The next thing we need to do is write the state for each substance in our net ionic equation. HF will dissolve, although it is a weak acid. We'll come back to that. KOH, potassium hydroxide, strong electrolyte. That'll dissolve in water there, aqueous. Compounds with fluorine and then also with potassium, very soluble. Water is a liquid. So we have the states. Now we can split the strong electrolytes into the ions. This will give us a complete ionic equation. We said that HF is a weak acid. In fact, this is probably a good table to memorize. So we see HF is not on our list of strong acids. So it's a weak acid. We can see KOH, that's a strong base. Because HF is a weak acid, even though it dissolves in water, it's not going to split apart much into its ions. So in our net ionic equation, we're going to keep this together as HF. I'll write the states later. Let's not do that right now. KOH, though, it's a strong base, a strong electrolyte. Potassium group 1 has a 1 plus charge. Hydroxide ion, the whole thing, 1 minus. So we have K plus this hydroxide ion, OH, minus. These are the reactants in our net ionic equation. So we have our potassium ion, K plus our fluoride ion, F minus, and then we don't split liquids apart either. And put a H2O there. So this is our complete or total ionic equation. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. I see I have a K plus and a K plus, so we can cross that potassium ion out. Everything else, though, is unique, and that's the net ionic equation for HF plus KOH. I'll clean it up and write the states in. We'll have our net ionic equation. So this is the balanced net ionic equation for hydrofluoric acid plus potassium hydroxide. You'll note that charge is conserved. We have a negative charge on this side, and we have a negative charge on this side of the equation. We also have mass conserved. We have 2 hydrogens, 2 hydrogens. 1 oxygen, 1 oxygen, 1 fluorine, 1 fluorine atom. So mass is conserved as well. This is Dr. B, and thanks for watching.